everybody, Brian here from quantlabs.net. Just wanted to show you a modified version of one of the finance demos examples from ChartDirector. In here you will find one of the examples here called finance. So what I did was I created a new modified version of it that will read in a CSV file, a comma separated value. Let me show you how you can manipulate data for starting ranges and how it works. So if you've ever seen my CSVs that are generated by the J4X, what you'll notice is, if I can find it properly, any one of these. So I have one here, this one, let's say USD Norwegian kroner. Actually, I have something already loaded up in my spreadsheet here. So we're talking about the euro, Japanese yen. You can see it's quite big, and it's an entire CSV that I've shown before, or how to read it, with over 4,800 rows. Doesn't really matter how it starts or whatnot, but all the way back to 2005. And all we're really doing is a variety of things here. So let me show you how this works. So what we do is we read in the CSV, what it is, specifically for, let's say, generated by J4X. We can then predefine the columns of timestamp, open, high, low, close, and volume. And then I've added in a new column called ChartTime. And the ChartTime is something that's specific for ChartDirector. Then I can set number of days or whatever you want, it doesn't really matter. And then, just as an example, this is the entire data frame that's read in. And then I'm only tailing the last number of days, which is 60 in this case. And then I predefine a counter called N for iteration or looping purposes. I predefine a list data type, and then here it gets a little hairy, but I'll try to do my best to explain it. So what I'm doing is I'm looping through the iterate through the data frame. Now remember, I'm only including the last number of days, which in this case is 60, as you can see here. And then what we do is we convert the data frame timestamp, the location, which is really the index, which is set at N, and then we convert that from a timestamp or data type of a date, and we convert it into a string. I'm just doing this the easy way so you can kind of pick it up fairly easily. And then what we do is we basically use something equivalent of a substring. So we're essentially grabbing the first number 0 based of the date string and then extracting the first 4 characters, which will give you the year. And then we do the same thing from 5 to 7 for the month and then day, and we skip between these two because they have a hyphen in them. And then what we do is we convert the equivalent of the year month strings into integers. And then what we can do is we can add those to the list. And basically the imports that we have are the finance chart for ChartDirector, and then we also are using pandas. So here, once we predefine the list, we can also add 1 to N, which is our loop counter here. And then once we get through the loop, which is usually going to be no more than whatever we set it at, tail or whatever, convert it from a list, or it's really an array here, to a series. That's what the SE stands for. And then we take the SE values, because there's an index in the values, and then add them to the new column called ChartTime. So then we set, everything else stays the same that we're used to, in finance. This data in this demo, so nothing really changes. But the only thing that really is affected here is, okay, so let me just remind you on the chart time. So if I was to do a chart director and then chart time, so what we're dealing with here is basically obtaining the time elapsed of what our time frame, date, string, and then converting it into this format for ChartDirector, and then it will return the elapsed time since here into any given time, or to the given time. That's passes the argument here. So that's what ChartTime does. So we get that, where is it? Up here. And then we just add that result to the list by pending it, as I said. So we can really ignore all this code here, all this RAND table stuff. We can just ignore. I've even commented out some of the other stuff. I could really comment out all this stuff. But what really matters is what we replace the timestamp, high data, low data, close data, volume data with. So we create the timestamp array with the chart time column that we created up here, okay? And then we add in our usual high, low, open, close volume that are read from the data frame, and then the names from the CSV that we are importing. So knowing that, create a finance chart object, I guess. Documentation is really good here. We add whatever title we want, and then we set the data. As I said, we set the data from up here, okay? Now this important one is the chart time, and this works. So this right here, this last parameter, let me just show you this important set data. Sets finance chart. So the name of the object is finance chart and set data, I believe. Yeah, so that's what we have. So we have set data, and then we pass in the time stamp, high, low, close, open, and then volume data, and then extra points, which is really number of leading time intervals that are splayed in the chart, and these are used for so something like moving averages. Okay, so we have all that defined here, and then we just add the main chart. You can pretty well figure out reading these columns here. Add a moving average, an SMA, Bollinger Band, volume bars, RSI, momentum chart, or and these are the nice things about these indicators. These are from ChartDirector, create or make a chart, and that's it. So when I run it, this is what we get. So it's all a hard-coded name. So we just got to go down here to the appropriate folder. So this is our ChartDirector for Python, and then we are looking for finance PNG right here. And that's our chart right there. Okay, so in a nutshell, we have obviously our price line, the moving average, as you can tell by a legend here, the Bollinger, and the volume. Then we add the RSI, momentum, boom, and we actually have working dates here. So that's pretty good. And you can see how easy it is. So if I change the number of days to, let's say, 600 instead, this should work okay. That should take us much farther back. Instead of 60 days, we're going back 600 days, which is what, roughly 2 or 3 years. So let's see how far back it goes. So here you go. Yeah, it starts all the way back to August 2016 with appropriate months, the year 2018, all the way including March 2018, which is the most recent here. So we have March 20th, 2018. So that's pretty cool. So you can see the pricing's gone up a little bit, and the charts are much better than anything with Matplotlib or even Seaborn. So hopefully I'll help you out. I'll include all the source code as well. Later.